So I'm going to deactivate these layers and I will go back to the Arc catalog, and I do not have so many different types of raster data over here. I just have one raster, which is a DEM, which stands for Digital Elevation Model. So if I drag this and drop it over here, you can see that in terms of the appearance, it's quite different from the vector data that we are used to seeing. And if I happen to zoom in like this, you can see that this entire image is actually made out of different pixels. I'm not sure if it's clear for you guys in this way or not, but for me, I definitely can see the boundaries of different pixels. And since this is a raster, each of these different pixels actually have its own value. And in this case, that value corresponds to the elevation with respect to the mean sea level. Now, in case if you're interested in knowing, let's say, what is the elevation somewhere around here, you can again use this identify tool and you can click on this, but make sure that you have turned on DEM from here, which is the TIFF layer. And when you click over here, you can see that the pixel value is 144. In this case, the pixel value corresponds to the raster value, which is actually the elevation. Over here, it's about 114. That's 114 meters above the mean sea level. And let's see if I zoom this out, and from here, sort of this stretch of the colors, you also can see that the darker areas correspond to lower elevations and the light areas correspond to higher elevations. So for example, if I were to select maybe a pixel from here, you see that the pixel value is 62. So that's about 62 meters. Whereas if I were to select maybe a point from here, which is this white color region, you can see that the pixel value is 262, which is actually a higher pixel value, which corresponds to a higher elevation. So I think you kind of get the idea of the differences between raster and vector data. And if I happen to activate maybe this reverse dissolve, normally these rivers are actually falling on lower elevations, because usually if you talk about the concept of something like a watershed, the river gets formed in the lowest elevation to which the water gets accumulated within a certain particular watershed or a basin. So that's why you see that along this line of the river, normally the pixel value tends to be lower. And these are the high elevations from which actually the water will flow into the river. So we can give that kind of a representation to raster data. Somehow if you're using the band between black and white, maybe the actual variations of the elevations might not be that apparent to you guys. So first, to get started, what I'm going to teach you guys is how to actually do different styling to your rasters. So similar to what we did for vector data, for raster data too, we can just go to properties and go to symbology. And from here, there are actually a couple of choices which we can work with. For example, if you want to use this stretched option, you actually have the possibility of selecting a color ramp from here, a different color ramp. I usually tend to go with this color ramp, in which the higher elevations will be attributed to blue color and the lower elevations will be attributed to brown color. And if I click on apply, you can see that these dark blue areas correspond to elevations of, let's say, about 800s. And these brown areas are corresponding to elevations of, let's say, -3, 0, or lower elevations like that. But for some reason, if you think that maybe the lower elevations should be corresponding to blue, because blue is usually associated with water bodies and lower elevations are the places where the water gets accumulated. If you think like that, you can actually invert this color ramp. Using this button over here, you can invert this, and when you click apply, you can see that the whole color scheme gets inverted. Means now the lower elevations are represented by blue colors and the high elevations are represented by those shades of brown. Now over here, one limitation is that the stretch of these different color bands are actually determined by the program for us. But let's say if you would like to create a classified image, you can divide these different elevation intervals depending on your preference. Now let's say if I were to select the same color scheme, just like this, you can now see that it actually groups the different ranges of elevations into different colors. Over here you can see that from -32 up to +64 meters. You can see that these dark blue colors are actually not just showing one single value, but it's actually showing a range of values from 443 up to 879. So this actually takes some detail out from the image, because now you don't exactly know what would be the exact elevation, because it only shows you a range. It could be anything between 443 up to 879. Now, one way to actually get rid of this inaccuracy is actually by increasing the number of classes. Let's say if you were to have 22 classes, you can see now the intervals are quite high, but the value range is low. And now if I press apply, you can see that now the picture gets a bit more detailed. And if I come over here, you can see from this sort of legend, now these dark blue colors are referring to these very high elevations, which actually again comes in between a range from 775 up to 879. Well, if the unique pixel values are not that important for you, then of course this is a good way to go. And again, if you wanted to flip the colors, in this case, actually you don't have a dedicated button to flip the colors. All you can do is you can click on this symbol button and you can select flip colors, and that'll kind of flip the colors back. And let's say if you want to manually determine the intervals by which you specify the range of the elevation, you can actually go to this classify over here and you can manually shift these intervals just like this. So these are the different intervals by which your raster will get sort of classified, if I may. As soon as you make a change over here, you can see that the classification method changes to be manual. But there are actually quite a few automatic classification methods as well. For example, if you specify equal interval, you will get the values divided equally in between the lowest and the highest value. As you can see over here, the gap is equal. I mean, it might be useful in certain cases, or you can use a method like quantile. In this case, you can see that when we go to the high elevations, you can see actually we have a bit of a higher gap, but the interval is quite low when it comes to the low elevations. You can try that as well, and that'll sort of create a different picture, but always you have to tally what you see over here with this legend that you have over here in order to meaningfully interpret your raster. Well, I think I prefer to go with the equal interval, and I'm going to maybe restrict this only to about 10 classes. I think that should be sufficient, even though I lose some detail because of that. So now you can get an idea about how you can actually do different types of styling. But then if you would like to retain the stretched option, you can always do that as well. Maybe you can go with a different color scheme as well, and we can invert this. Alright, now I'm going to teach you guys how to blend your workflows with raster data and vector data. So you can see over here actually the raster is quite huge. If I use my measuring tool to measure the actual distance in kilometers, you can see the width is about 68 kilometers and the height is about 111 kilometers, which is actually massive. I do not really need all of this additional information which is present over here. So next, what I'm going to teach you guys is how to actually clip a raster using a polygon. I think you guys remember how to clip polylines using polygons, which I discussed with you guys in the first part of this tutorial. But now I'm going to sort of isolate only the piece of the raster which is relevant to me, not really everything that we might not really need. Now the things that I might have over here is, let's say I have the region of interest parts over here, but I feel like I would like to capture this entire area which corresponds to these two rivers as well. Alright, so what I'm going to do is I'm going to actually create a new polygon which encompasses these two rivers. I'm just going to randomly create that polygon. And after that, I'm going to clip the raster based on that polygon. Let's see how that works out. So what I'm going to do is I'm going to go to shapefiles first and I'm going to create a new shapefile. I'm going to create I'm going to name this one as raster boundary, and it's going to be a polygon. Well, this is something important that you need to keep in mind. If you're clipping two different items, you have to make sure that the coordinate reference system of those two items are same. So I'm going to take a step back and I'm going to check what is the coordinate reference system of this raster is. If I go to this source over here, you can see that, yeah, the spatial reference is WG is 1984. So if I wanted to clip my desired part just by looking at this graphical interface, I need to make sure that I have my corresponding polygons in the same coordinate reference system as well. So I'm going to recreate this one, which is the raster boundary, and it's going to be a polygon, and over here. Now it's not going to be UTM zone 30. Now it's going to be geographic coordinate systems, world, WGS 1984. That's the same exact coordinate reference system which corresponds with the DEM as well. So I can click OK. After that, the same workflow. Let's say I'm going to first remove the fill color and maybe create just a thick outline. And after that, I'm going to turn this to be on the editing mode. And after that, I will select on create features, maybe get rid of the catalog for the time being. And I'm going to specify the polygon, let's say in this manner. It's just a random specification of a boundary. Yeah, something like this. Now we have the polygon all set to go, so I can stop editing and save my edits. And now I'm going to actually perform the clip operation on this particular raster based on the boundary that I have specified over here. So you can do that simply by again opening up the search panel. And by now I think you guys can realize that I'm very frequently using the search panel because I can recall what sort of a tool that I'm looking for. And I'm pretty sure that after a while, if you guys continue to use ArcMap, you'll be also doing the same. Alright, so I'm going to search again clip. And this time, since I'm going to cut out a portion of a raster, I will not go with clip analysis, I will go with clip data management. And from here you can see that it asks us to specify the raster. And I'm going to simply drag this one and drop it over here. And I would like to set my output extent to be this raster boundary, but very important, I have to tick use the input features for clipping geometry, even though it's optional. Otherwise you will actually just get a box with the extents of this raster boundary, but not really get the raster clipped according to the exact boundaries of the polygon. So that's why you have to tick this one, and then after that you can click OK. Well, I think I forgot to specify the path to which this file will get exported. In case if you happen to forget something like that, actually you don't have to worry much. Either you can do the whole operation again, or what you can do is you can simply export this raster simply by right clicking over here and go to export data, and from here you can open up the location. So I would like to actually put this into this raster folder. So I select the folder and click on add, and this one I would like to specify the name of the raster to be raster clipped, and the format will be geotiff. And this time I would actually like to add that corresponding raster to my working space so that I can actually get rid of this DEM clip, which we no longer need. It's basically the same thing. And if you look at the color scales over here, you can see this big DEM varies from -32 up to 879. But this raster clipped, which is actually this part, the elevations value only ranges from -3 up to 374. Because it's actually a small region, so it's not capturing all of these higher values and even the extremely lower values. So I can even turn this bigger DEM layer off. Well, I'm going to push this reverse on top of this. So similar to what we did, I'm going to right click over here, go to properties, and first make some changes in the symbology. I'm going to select a different color ramp. Well, I tend to go with this color ramp for some reason, even in most of my tutorials. So I'm just going to stick with this one because maybe it looks visually pleasing a bit more than others. So click OK. And again, if you would like to check out the different pixel values of this raster, you can always go to this identifier tool. Let me get rid of this one and select once and make sure that you actually select the corresponding layer. In this case, it's going to be raster clipped. So let's say if I select one of these darker red areas, it's going to show me the pixel value about 365 meters above the mean sea level. While I come to the sea level, and if I check over here you can see the pixel value is 0. So it's basically at the mean sea level. If you happen to see negative values, in this case actually it's at the mean sea level, but if you happen to see negative values, that means those locations have recorded an elevation which is lower than the mean sea level. So mean sea level is basically an average of the sea level. long-term average, which is generally considered as a 0 point. Alright, that was how to clip a raster. So the next thing that I'm going to teach you guys is how to weave a cross-section when you have a DEM like this. And you can simply do that using the 3D Analyst tool. Now before doing that, you have to make sure that you actually activate your 3D Analyst extension. You can go to Customize and go to Extensions. And from here you make sure that you have activated this 3D Analyst option over here, which is an extension. Alright guys, I got rid of all those unwanted layers and only retain this raster clipped raster and this reverse dissolve, just to get some perspective of the reverse, as we can see over here. Now since you're trying to actually create a cross section, we are going to deal with X and Y data, and it's always good to convert the coordinate reference system to a projected coordinate reference system before we actually proceed on to create the cross section. So as you can see over here, if I check, still the spatial reference is in geographic coordinate reference system of WGS 1984. So I'm going to call the search panel again, and from here I'm going to search project raster. And the first item, you can see that we have the data management project raster option, and I'm going to simply drag this and drop it over here and first set the output path. I'm going to say raster UTM zone 30 north, and the output coordinate system will be projected UTM 1984 northern hemisphere and zone 30 north. I think you can click OK. After a while you'll be able to see the reprojected raster, and if you check the coordinate reference system, you'll be able to see that it's in WGS 1984 UTM zone 30 N, as you can see over here. Alright, so I'm going to deactivate this raster which was in WGS, which was in the geographic coordinate system, and let me just go ahead and pull this one up. And again, yes, I have to change the symbology just because it looks a bit more pleasing than the black and white one. Yes. Now let's say that we want to create a cross section, let's say across somewhere over here. So since we have already activated the 3D Analyst tool, all we have to do is now activate this 3D Analyst toolbox. And from here, make sure that you have selected the corresponding raster. In this case, it's going to be the raster of UTM zone 30N. And after that, you can create a line of sight by clicking on this button. And let's say my line of sight is going from here up to here. So this is actually the line across which the cross section actually will get generated. So after you do that, make sure that you have selected this, and you can click on this profile graph item, and now you can see that this is how the profile graph looks. So this red color button actually corresponds to this right side, and now you can see if the starting point was 0 meters, then by the time you reach about 12,000 meters, you can see how the elevation actually varies across this profile from the starting point up to the ending point. And you can see that the elevation actually varies from about 40 meters all the way up to about 100, almost up to about 160 meters. So this is how the elevation actually varies across this. So that's how it extracts basically the raster value which corresponds to each and every pixel which gets crossed by this line of sight, and it creates this cross-sectional profile. Now what I can do is I can actually select this line of sight and delete it, and I can create a new line of sight, maybe by zooming this one in. And if I create the line of sight just like this, just across the river, you can see that if I create the profile, you can see somewhat clearly that it captures the lowering of the ground level when it comes to the river. So this could probably be the river water level. Just one thing to keep in mind is that this is actually SRTM data, Shuttle Radar Topography Mission, and they're not able to capture the river bathymetry. So what you see as the lowest point could very well be the water level of the river, but not really beyond the water level. So that's why you might see a flat line over here. So this could really correspond to the water level of the river, and you can see that when we go to the other side of the river, again the terrain actually rises accordingly. So that's how you get the cross section, especially when you're working with DEM data if you wanted to do a quick visualization. And next I'm going to teach you how to actually transfer this information into ArcScene and create a 3D diagram or a 3D weave of this exact DEM, because now we are working with elevation data. So since we have already activated this 3D analyst toolbar, we don't have to specifically open ArcScene separately through the Windows Explorer. You have this button over here which is the ArcScene link. When you click on that, you will see that ArcScene will actually automatically get opened. So the window of ArcScene actually looks somewhat similar to ArcMap, but there are a few differences. But similar to ArcMap, you can find your catalog on the right side over here. Now what I'm interested in is this raster UTM 30 zone elevation raster. So I'm going to navigate again to the same location to which I have saved that raster, and I will drag it and drop it over here just like this. And now you can see that when you move your mouse cursor just like this after selecting this navigate tool, you can sort of navigate around the DEM in sort of a three-dimensional way, but you can see the layer itself is actually not 3D yet. So now we will see how we can sort of pop this one up based on the elevation values of the raster. Again, if you're using the mouse, you can use the mouse scroll wheel as a button in order to move this, to pan this one around, or you can simply use this pan tool just to move this around. And I'm again going to go to properties and make sure that I go to symbology, and similar to what we did before, I'm going to select my colors of preference. And now in order to activate the 3D properties of this, I can go to properties and go to base heights, and from here make sure you select floating on a custom surface, and after that you can click apply. And now if you try to use this navigate tool and try to move it around, you will see that things change just a bit, but not too much. So what I'm going to do is I'm going to go back to properties again, and I'm going to increase this factor to convert the layer elevation values to scene units by, let's say, 5, just to test. Yeah, now you can see that it's sort of vertically exaggerated the Z values, and now you can see the clear-cut rivers. If you sort of want to visualize this with the perspective of a watershed, you can see that the water will actually flow into this side, and from here the water will actually flow into this side, into the river. The natural flow path has been carved out from this side as well, which corresponds to those two rivers. And if you would like to increase the vertical exaggeration, maybe about 10, I'm not sure if it'll be too much or not. Yeah, I think it's just good enough. So from here you can actually get a very clear view of how your raster look in a three-dimensional view as well, which can be quite helpful actually, just to get a grasp of how your elevation raster might look. So since this is a beginner's tutorial, I'm not going to dive much into detailed stuff even with ArcScene, so I'm just going to leave it at this. Just wanted to show you guys how we can sort of quickly transfer a raster like this to get a 3D view using ArcScene while we are working inside ArcMap itself. So I'm just going to go ahead and close this one out. Alright, next I'm going to tell you guys how to obtain spatial statistics or zonal statistics using raster data. Now as you can recall, all of these values, all of these colors that we see are actually corresponding to different pixel values. So let's say there's a specific region for which you would like to average out all the pixels, and you want to kind of get the average elevation value over a certain area. Now if you want to do something like that, if you were to do it manually, the way that you would do is would be you pick the pixel value of each of the pixels which falls inside that region, you add them all up, and then you divide by the number of the pixels, which will actually give you the average elevation value. But this kind of statistical operations can be very easily done using the zonal statistics tool of ArcGIS. So what I'm going to do is I'm going to first create a search for that tool. Yeah, I'm going to select this zonal statistics spatial analyst tool. Again, you have to make sure that you have activated the spatial analyst extension under this extension option. Well, before that, I would like to actually create an area of interest, a small area of interest. Well, let me see if I can use my region of interest. One looks like something like this. Well, I think I'll just go ahead and create a new shapefile, a small shapefile, a polygon type shapefile. New and shapefile, and I'm going to name this one as area of interest, and it's going to be again a polygon. Since I'm going to extract the values from this reprojected raster, I'm going to select the same projection of that reprojected raster, which is UTM zone 30. Yeah, and I'm going to follow a similar workflow in order to create. First, I activate the start editing, and after that, I can go ahead and create features from here. Well, this time, let me just go ahead and maybe select a rectangle. So if you want to select a rectangle over this area, this small area, yeah, I think you can see that now it's done. We can go to editor and go to stop editing in order to stop all the edits. And now I will go back to this zonal statistics tool. Yeah, over here, I have to first specify the zone. Now my zone is actually this area of interest. So I'm going to just drag it and drop it over here. And I can select any zone field, wouldn't matter much. And the raster which contains the values for which I would like to perform this statistical operation is actually this raster UTM 30. I will drag it and drop it over here. And from here you can see what sort of statistical operations we can get. Now we can calculate the mean, the majority, maximum, medium, minimum, minority, range, standard deviation, sum, and variety. So let's say I would like to take the mean, the average. And if I click OK, you can see that it actually creates a new raster, and that raster has a constant value, which is 52.3851, and that gives us actually the average of all the pixels inside this particular area of interest. Now similarly, if you would like to export that information into a table, that's possible as well. You can see zonal statistics as a table. So I'm going to follow the similar workflow, and in this case the input values will be coming from, the raster values will be coming from here. And since it's a table, it actually has option for calculating all of these different statistics, not just one. So we can just specify all, and after that we can click OK, and you can see that it actually creates the table which I can open and view just like this. Now you can see again here the minimum pixel value, the maximum pixel value, the range, the mean. If you can recall, this mean is actually the same average which was calculated just a few minutes ago. Just like that, you can actually get the zonal statistics based on a given area of interest, which can come in handy in certain specific applications. Alright, I'm going to flip this back to list by drawing order. And the next thing that I'm going to discuss is actually how to convert a raster into a polygon. Now, one of the examples that I can think of is that if you would like to segment this particular raster into elevation groups, and if you would like to export those different zones into separate polygons, I think you can recall we did some sort of a classification using this classified option, where I divided the whole raster into a number of classes, and based on this, when I click apply, you can see that it actually generated different zones of elevation, just like this. And what if you wanted to export this into a polygon, so that you can calculate the area which corresponds to the elevation values ranging from -3 up to 48. Things like that you can actually calculate if you are able to convert this into a polygon. Well, there are other applications as well. So now we will see how we can do that. So one of the ways of doing that would be to permanently reclassify this raster. Now, even though I did this kind of a classification, this is just a classification for the purpose of viewing the raster, but the raster itself still consists of individual pixels which forms the entire digital elevation model. But if we want to, let's say, export these kind of elevation segments into a vector or into separate polygons, what you can do is you can actually use the reclassify tool. And from here, I will go with the reclassify spatial analyst tool. And if I were to input this raster, now you can see that these same ranges actually got applied over here. But now the new raster values are specified in this manner. It just has simple value. If you want, you can actually change this one. Doesn't really matter. But you will just have to keep in mind that these different values are corresponding to different elevation ranges. I'm going to name this one as reclass. And just keep in mind that this raster will be a new raster which will sort of group these elevation ranges into these specific new values, as you can see over here. So I will click OK to export that. Yeah, now you can see that it generated a new raster called reclass. But now if you check the attributes table, this is the raster count, and you can see that the raster values are just only 1, 2, 3, 4, 5. And if you can recall, this 1 is actually corresponding to these elevation ranges from -3 to 48. 2 is from 48 to 93. 3 is from 93 to 150, and so on. So this is something that you can actually convert into a polygon. Now, to convert this raster into a polygon, what I can do is I can say raster to polygon. And you can go with the first tool, raster to polygon. And what I'm going to do is I'm going to drag this reclassified raster. And now since it's a polygon, I'm going to open the shapefiles and say elevation ranges and click OK. Yeah, now you can see that it actually converted everything into polygons. Now if I open that up, you can see that this grid code, if I double click on this grid code number 1, if I were to select all the number 1 grid codes, you can see that what gets selected over here is actually corresponding to this particular number 1, which happen to be the elevation values which correspond to -3 up to 48, and the grid code of number 2 will be the elevation range 2, which is corresponding to 48 to 93, and so on. And if you can recall what we did in the earlier session, it would be actually convenient to have all of these grid codes which has the same value merged together. We can use the dissolve tool in order to do that. So what I'm going to do is I'm going to call the dissolve tool, and I will input these elevation ranges, and I will make sure that I click on the grid code so that it'll merge everything which has the same grid code into one single polygon. Now if I open this, yeah, now you can see that this is a grid code 1, again corresponding to this particular elevation range. I'm thinking that maybe it would be good to add something like a descriptive column. And I'm going to make this a text column. And I will add some information about these elevation ranges. So I will go and click on edit features and start editing. And I will mention that this grid code number 1 will be elevations from -3 up to 48. Well, I'm just going to ignore the decimal points just for the time being. (93), and this third one is going to be elevations from 93 up to 150, and this is going to be elevations from 150 up to 224, and finally this is going to be elevations from 224 up to 374. Yeah. After you're done with everything, you can go to editor and stop editing, and it'll prompt you to save your edits. And if you deactivate everything now and only keep that converted shapefile which is of type polygon, you can even go to properties and go to symbology, and from here if you go to categories, you can specify the categories based on specific value field over here. Now you can either go with the description or you can either go with the grid code. Doesn't really matter, because even the description and the grid code will be unique for each type of elevation range. I'm going to go with grid code, and now you can maybe select a color band from here. I'm going to maybe select this set, and after that you can say add all values, and it'll add random values. If you don't like these values, you can maybe click again. You can click until you get the colors that you like, or you can manually go over here and actually double click and change the color, and I can click apply, and now you can again see that this number 1, which corresponds to elevation values from -3 up to 48, are represented actually over here. And now just because this is a polygon, you can do other things which you would normally do with polygons. For example, if you would like to add the labels, you can go to the labels. I'm not sure how messy this would be, but let's see how it looks if I add the description to be my label. Apply. Yeah, you can see that. Well, to see the description quite clearly, you might have to zoom in to your area of interest, but you get the idea. I think I'll get rid of that because it looks a bit messy. And not only that, what I wanted to do was I wanted to calculate the area which corresponds to elevations ranging from, let's say, -3 to 48, 48 to 93, and so on. And now, since this is of type polygon, you can do that quite simply by creating a new column over here, area, and I'm going to go with maybe double. Click yes. And now I'm going to say calculate geometry, and I would like to see the area in square kilometers over here. Just make sure that you select area and it's in square kilometers, and when you click OK, you'll be able to see that the area which corresponds to the elevations ranging from -3 up to 48 is 123 square kilometers, 48 up to 93 is 127. So you can see that the mountainous regions ranging from 224 up to 374 is just only 22 square kilometers, which correspond to these brown patches over here. Alright guys, I think we covered quite a lot of things in this tutorial. I hope that if you were a beginner at the beginning of this tutorial, now you're able to do actually quite a number of things, isn't it? So that's why I promised you guys that this tutorial will take you to a certain level just within a matter of few hours. Right now you might be able to do only the things that we did. Probably that's how it is when you're actually learning something for the first time. But of course, over the course of time, you can actually practice and you can learn how you can apply these concepts which we learned to your own specific task. And that's how actually you keep on improving yourself to get better at using this software. Alright, now I'm going to head to the final part of this tutorial, and that's going to be how to put all of this information into a map. Now, so far what we did was so many different types of geospatial operations, but it's of no use if you cannot actually present the story in a meaningful manner, let's say to a client of yours or a friend of yours, to actually explain the story that you would need to say through your map. That's why you need to learn how to actually accurately present this kind of a map to somebody else in case if you need to do that. So before I conclude this tutorial, I'm just going to show you how you can create a quick map layout using ArcMap. And you can export that, and once we have done that, you can actually export that map as a PNG or JPEG, and maybe you can print that out if you wish to. So let's see how you can do that. Now, I'm actually going to present this result which we obtained, which corresponds to the elevation ranges, as the product that I would like to present. To sort of have a filling background, I would like to add my base map again. So I'll just go over here and go to add data and go to add base map. And I will again add the OpenStreetMap just as a base layer. Now again, my story will focus mainly on these different elevation ranges. So what I don't want to do is actually to put people's attention into this base map too much. So what I will do is I'll just go to properties over here and increase the transparency to about 20%, so that the map will still be there, but the amount of attention the map grabs from the reader will be actually less. So I'm going to maybe increase this up to about 40%. Yeah, I think should be fine. And right over here at the bottom, you will see that so far we were working on this data view. What we need to switch is to the layout view over here. So I'm going to click on this layout view, and you can see that, well, we get the layout view, but there are so many things to be adjusted or corrected. So the first thing that I'm going to do is I'm going to flip this page to be a landscape page. So I will go to this change layout, and over here, the page sizes, I'm going to say I would like to have a A4 size landscape. And after that, if you would like to zoom this to fit into the size of your page, what I will first do is I will actually drag these corners like this. And you can see that we still have some room to sort of zoom this one in. So in order to zoom this in, you can actually use this zoom in tool and zoom this one in like this. And after that, you can take the pan tool and you can actually pan it around just like this, because I'm trying to leave some space to create a legend over here and maybe add a title over here as well. Alright, I think this should be fine. The next thing that I would like to do is maybe I will correct this one from here just a bit. Maybe these sides as well. Yes, the next thing that I would like to do is to add a north arrow. So I can go to insert and I can create a north arrow from here. And you can see that there's a wide variety of north arrows from which you can choose one. I'm going to go with this S3 north arrow because it's just a bit plain and quite simple as well. Yeah, just like this. And next I would like to add the scale bar. So I will go to insert and go to scale bar over here. And usually I would like to have the scale bar maybe something like this. So of course you can actually check the properties and then see how you can alter the scale bar according to your preference, but I'm just going to go with the standards over here and I'm going to select OK. And you can see that it's in kilometers. And if I drag the scale bar, you will see that the units also change. Sorry, not the units, but the numbering also changes accordingly. Well, I think I would like to make a bit of a change over here. So I'll double click on this and I would like to change the font size to be about maybe 12 and make it bold. Yeah, I think should be fine. Maybe drag this one just a bit. I think this scale bar should be fine. And next I would like to add one legend. Now in the legend I would like to add only maybe this layer. I can go to insert and go to legend. And from here you can select which items that you would like to actually add into your legend. Now over here you can see by default it selected this particular layer, but for some reason if it appears to be something like this, you can always select the corresponding layer and push it to the legend items side. And I will go over here to next, and I will, well, for the border I will select a line, and the background I would like to maybe keep a white background and maybe increase the gap just a bit and go to next. And after that you can simply click OK. Alright, now you can see that actually the legend is over here, but there are a few things which are not really meaningful when the legend appears like this. So I would like to go back to properties over here, and in symbology, instead of splitting this based on the grid code, I'm going to split this based on the description. and I will say add values like this. And now you can see that the description actually changed. I will get rid of this all other values because I don't really have any other values. And I think this pretty much does it for me. If I do not want to have anything over here, what I can do is I can click over here once and delete it. And that gets rid of this particular description. And over here, whatever the heading that I would like to add as the layer heading, I can just type it in, just if I were to rename this layer. So I can say this is meters above mean sea level, something like this. Now you might think that maybe we might need to change a few things. For example, increase the font size. You can do those things quite easily from here. Yeah, over here I'm going to select apply to class labels, and I'm going to increase the font size to be about maybe 12 and make it bold as well. Yeah, you can see that now it got added actually to this part. And I will apply to the layer name and maybe change the font size to be about 16. Yeah, you can see that the layer name got increased. The size of the layer name got increased as well, just like this. I think this should be good enough. And finally, I'm going to add one title. Elevation ranges based on SRTM DEM, Digital Elevation Model. And this title, you can drag it and drop it over here. Of course, double click and you can change the properties associated with that particular text simply by, let's say, increasing the font size and the font type as well. Well, I'm going to use Arial Black for that. And click OK and apply and see how it fits. Yeah, I think this should be okay for me. Yeah, now after you do everything, if you still feel like you want to do some minor adjustments of your map, of your base map, you can do it simply like this, just to make sure that everything is correctly in place. Alright guys, I think this should be it. I will try to export this map now. So in order to export this map as a JPEG or even a PDF, you can go to File and go to Export Map. And from here, I will select the type to be JPEG. You can of course increase the DPI value. I'll put something about 150 and navigate to the place where you'd like to save your file. And I will create a new folder called Map. And name this one as elevation ranges and save this, and it'll take a while to export. After everything is done, you can go back to your desired folder and you see that JPEG right over here. If I were to open this, yeah, this is how the map looks. Quite interesting, isn't it? Alright guys, I think that concludes the tutorial. We covered quite a number of things starting from the very first part of this tutorial. We talked about the vector data, how to perform different spatial operations on vector data, and then we moved on to the raster data. And finally, we created a beautiful map, which is of course in publishable quality, depending on the type of the analysis that you actually want to present. So that's about it for this tutorial guys. I really hope that you as a beginner got a very thorough understanding of what the capabilities of ArcMap are. And personally, I prefer the style of learning by doing. So again, I encourage you guys to actually follow the tutorial along from the very first minute until the end, following each and every step. And once you really acquire that, you'll be able to apply these concepts to your own cases without an issue. It's guaranteed. So thanks a lot for sticking with us guys. If you did like the tutorial, you know what to do. Show your support by hitting that like button and comment down anything if you really need to get something clarified regarding this tutorial, and we'll try to respond as soon as possible. Stay safe guys, thanks a lot, and I'll see you in the next one.